Hello there. Come on in and make yourself comfortable. You found Science Blanket, and I am so happy you're here to share this quiet space with me. Have you ever sat by a river and felt like the water was carrying the weight of the world away with it? Tonight, we're wrapping ourselves in the story of these ancient, flowing pathways. We often think of rivers as simple water moving toward the sea, but did you know that some rivers are older than the mountains themselves? Some, like the Finca in Australia, have been flowing for over 300 million years, witnessing the rise and fall of dinosaurs and the shifting of entire continents. Tonight, we aren't just talking about geography. We are drifting through the Earth's oldest memories, from rivers that flow hidden beneath the ice of Antarctica to a secret, invisible river that runs deep under the streets of Manhattan. As we begin, imagine yourself resting on a small, sturdy boat, drifting down a river so calm it looks like a mirror for the stars. There is no destination and no hurry. You don't need to remember the thousands of bridges crossing the Danube or the depth of the Congo. Just let the steady, rhythmic pull of the current tuck you in. If this blanket of flowing water helps you find peace, I'd love for you to subscribe and join our community of sleepy explorers. It helps us keep the stories moving for every soul in need of rest. Now, let's take a slow, deep breath together. Feel your body sink into the mattress, letting it support you just like the water supports a leaf. Release the tension in your jaw, let your shoulders drop away from your ears, and feel the day's worries dissolve like salt in the stream. You are safe, you are still, and the water is taking care of the rest. Let's explore the quiet wonders of the river together. There's something profoundly calming about understanding rivers, those ancient pathways of water that have shaped our world since long before humans walked the earth. A river is a natural flowing watercourse, and while that might sound like a simple definition, it captures something essential about the character of our planet. These are freshwater systems, almost always moving with purpose and persistence toward an ocean, a sea, a lake, or sometimes joining with another river to continue the journey together. They're not standing still, not waiting, but always flowing, always moving forward with a patience that spans millennia. When you think about water and where it goes, rivers become central characters in that story. They're a major component of what we call the water cycle, that endless circulation that keeps our planet alive and dynamic. Rivers are the delivery system, carrying water from precipitation, from rain that falls on distant mountains, from snow that accumulates through long winters, from ice that melts when warmth finally arrives. They gather all this water and carry it back to larger water bodies, completing a cycle that has repeated itself countless times since water first collected on Earth's surface. Every river begins somewhere, and those beginnings are often quiet and humble. Rivers typically originate from springs that bubble up from underground aquifers, or from glaciers that release their frozen water as they slowly melt under the sun's influence. Sometimes a river starts simply as rainfall runoff, countless droplets joining together on slopes and hillsides, finding each other and gathering strength. In mountains, headwater streams form, small trickles at first, emerging from the landscape where elevation and geology create the perfect conditions for water to begin its descent. These origins might seem insignificant, just small streams you could step across, but they're the beginning of something that might eventually become a mighty river carrying millions of gallons of water every single day. As rivers flow, they become sculptors of the land itself. They erode rock and soil with a persistence that's hard to comprehend in human timeframes. The water carries tiny particles, and these particles act like sandpaper, grinding away at the riverbed and banks. Over millions of years, This process carves valleys that can stretch for hundreds of miles, canyons that plunge thousands of feet deep, and gorges with walls that rise dramatically on either side of the rushing water. The Grand Canyon, perhaps the most famous example, was carved primarily by the Colorado River over approximately 6 million years. That's the kind of timescale rivers work on, slowly but relentlessly reshaping the surface of our world, cutting through layers of rock that represent hundreds of millions of years of geological history. If you've ever looked at a river from above, or traced one on a map, you've probably noticed that rivers rarely flow in straight lines. Rivers often meander rather than flow straight, creating those distinctive curves and loops that make river valleys so recognizable from the air. This happens because water naturally seeks the path of least resistance, and even tiny variations in the landscape cause the flow to curve slightly. Once a curve begins, it tends to intensify. The water on the outside of a curve flows faster and erodes the bank more aggressively, while the water on the inside flows slower and deposits sediment. Over time, these curves become more pronounced, creating the winding patterns we associate with mature rivers. The channels shift over time too, sometimes dramatically during floods, so a river's path today might be quite different from where it flowed a century or 1,000 years ago. All that erosion means rivers are constantly carrying material downstream. Sediment carried by rivers includes everything from fine clay particles to sand to small pebbles, all suspended in the water or rolling along the bottom. This sediment doesn't just disappear. It's deposited where the flow slows down, and this process creates some of Earth's most distinctive and productive landscapes. When a river reaches flatter land or encounters an obstacle that slows its movement, it drops the heavier particles it's been carrying. Over time, this creates deltas where rivers meet seas or lakes, and floodplains along the river's course. These aren't just geological features, they're incredibly important for life. Floodplains are highly fertile due to nutrient-rich sediments deposited by floods. When a river overflows its banks, it spreads a layer of fresh sediment across the surrounding land, and this sediment contains minerals and organic matter that make the soil exceptionally productive. This is why some of humanity's earliest civilizations developed along rivers like the Nile, the Tigris and Euphrates, and the Indus. The annual floods weren't disasters but blessings that renewed the soil and made agriculture possible. Not all rivers flow year-round, and this might be surprising if you've only experienced rivers in wetter climates. Some rivers are intermittent, flowing only during wet seasons when rainfall or snowmelt provides enough water to fill their channels. During dry seasons, these rivers might become a series of disconnected pools, or their beds might dry completely, leaving only sand and rocks where water once flowed. These intermittent rivers are common in arid and semi-arid regions, and the ecosystems around them have adapted to this rhythm of abundance and scarcity. Plants and animals in these areas have evolved strategies to survive the dry periods and take advantage of the brief times when water is available. Where rivers finally reach their destination, where they meet the ocean or flow into a lake, something remarkable happens. River deltas form where rivers meet seas or lakes and split into channels, creating a fan-shaped deposit of sediment. The river has been carrying this material for hundreds or thousands of miles, and now, as it finally slows in the relatively still water of its destination, it drops its load. The main channel splits into smaller distributaries that spread across the delta, constantly shifting and changing. Deltas are dynamic places, growing outward as more sediment arrives, subsiding under their own weight, responding to tides and waves. They're also incredibly rich ecosystems, home to unique plant and animal communities adapted to the mix of fresh and salt water. For all their importance, for all the way they dominate our maps and shape our landscapes and support our civilizations, rivers represent an almost incomprehensibly small fraction of Earth's water. Rivers contain only about 0.0002% of Earth's total water. Let that settle in for a moment. All the rivers on our planet combined, from the Amazon to the Mississippi to the Nile to the Yangtze, every flowing watercourse everywhere, contains just 0.002% of all the water on Earth. The vast majority of water is locked in oceans, about 97%, with most of the rest frozen in ice caps and glacier or hidden underground in aquifers. Yet this tiny fraction flowing in rivers has been essential to life on land, shaping continents, creating fertile valleys, providing water for drinking and irrigation, enabling trade and transportation, and creating the conditions for complex societies to develop. Rivers prove that significance isn't always about quantity. Sometimes the most important things are defined not by how much exists but by movement, by flow, by being in the right place at the right time, connecting sources to destinations, mountains to oceans, rain to sea, in an endless cycle that sustains the living world. Rivers are far more than just channels of flowing water. They're crucial habitats supporting fish, birds, and freshwater ecosystems that depend entirely on the unique conditions rivers create. These flowing waters provide food, shelter, breeding grounds, and migration routes for countless species. Fish have evolved to navigate currents, to find quiet pools for resting, to spawn in specific types of gravel or vegetation. Birds gather along riverbanks to feed on insects, fish, and plants, building nests in the trees that grow thick where water is abundant. The ecosystems that develop around and within rivers are intricate webs of interdependence, where every species plays a role, where the health of the water determines the health of everything connected to it. When you consider that freshwater ecosystems support a disproportionate amount of biodiversity relative to how much of Earth's surface they cover, rivers become even more remarkable. They're ribbons of life threading through landscapes that might otherwise be far less hospitable to the diversity of creatures that inhabit our world. Some of the animals living in rivers today carry with them an almost unimaginable depth of history. Freshwater turtles in rivers trace their lineage back 200 million years, which means their ancestors were already ancient when dinosaurs walked the earth. These turtles have survived multiple mass extinctions, adapted to countless climate changes, watched continents drift apart and new mountain ranges rise. The basic body plan that allows them to thrive in rivers, that hard protective shell, those webbed feet for swimming, that ability to breathe while submerged for extended periods, has proven so successful that it's persisted across eons. When you see a turtle basking on a log in a river, you're looking at a design that has worked for longer than most species have existed, a living connection to an Earth that was profoundly different yet similar enough in its basic patterns that turtles found their niche and held it through unimaginable change. Some rivers create conditions for life on a scale that staggers the imagination. The Amazon River Basin hosts the largest tropical rainforest on Earth, a vast green expanse that produces about 20% of the world's oxygen and contains perhaps 10% of all species on the planet. The river itself is fed by over 1,000 tributaries, some of them enormous rivers in their own right, and together they drain an area of more than 2.5 million square miles. The water flow is so immense that the Amazon discharges more water into the Atlantic Ocean than the next 7 largest rivers combined. This abundance of water, combined with consistent warmth and sunlight near the equator, creates conditions where life explodes into almost overwhelming diversity. Trees grow hundreds of feet tall, their canopies forming layers that create distinct vertical habitats. Countless species of fish navigate the river and its flooded forests. Insects exist in such variety that scientists estimate we've only identified a fraction of them. The Amazon system demonstrates what rivers can do when conditions align perfectly, how water flowing through a landscape can support a living system of almost incomprehensible complexity and richness. Not all river-fed ecosystems look like dense rainforest. The Okavango River in southern Africa creates something entirely different but equally remarkable. The Okavango forms grassy delta islands home to elephants and flamingos, a wetland paradise in the middle of the Kalahari Desert. What makes this especially unusual is that the Okavango Delta is an inland delta, meaning the river doesn't flow to the ocean but instead spreads across the flat landscape and eventually evaporates or seeps into the ground. During flood season, water spreads across thousands of square miles, creating channels and lagoons and islands. Elephants wade through the shallows, feeding on aquatic plants. Hippos lounge in deeper pools. Flamingos gather in the thousands where water conditions create the right food sources. Lions and leopards hunt on the islands. The entire system pulses with the rhythm of wet and dry seasons, expanding and contracting, but always providing a refuge for wildlife in a region where water is precious and rare. Rivers can exist in places you might never expect them. An underground river in the Philippines flows through a cave system and hosts over 100 animal species that have adapted to life in complete or near-complete darkness. This underground river carved its path through limestone over millions of years, creating chambers and passages that extend for miles beneath the surface. The ecosystem that has developed there is bizarre and wonderful. Bats roost in the caverns, their droppings feeding an entire food chain of specialized insects and other invertebrates. Fish that live in the underground river have evolved to be blind, having no use for eyes in perpetual darkness, instead relying on other senses to navigate and find food. Crabs and shrimp scuttle along the bottom. The cave walls host unique bacterial communities. It's a completely different world from the sunlit rivers we usually think about, yet it demonstrates how adaptable life is, how rivers create opportunities for species to evolve and specialize wherever water flows. Some river-dwelling creatures have developed extraordinary abilities to cope with their environments. The Ganges River dolphin uses echolocation to navigate muddy water, emitting clicks and interpreting the returning echoes to build a picture of its surroundings. The rivers of the Indian subcontinent often carry heavy loads of sediment, making visibility nearly zero, so eyes provide little advantage. These dolphins have adapted accordingly. Their eyes are extremely small and lack lenses, essentially non-functional for seeing in the way we understand it. Instead, they've evolved sophisticated echolocation abilities, swimming on their sides, using sound to detect fish, navigate obstacles, and communicate with other dolphins. They represent one of only a few species of river dolphins in the world, and they're remarkably different from their oceanic cousins, shaped entirely by the specific challenges and opportunities of life in large, murky rivers. Rivers can also produce creatures of truly impressive size. The Mekong giant catfish can grow up to 10 feet long and weigh over 600 pounds, making it one of the largest freshwater fish in the world. These enormous fish migrate through the Mekong River system in Southeast Asia, spending parts of their lives in different habitats as they grow from tiny fry to massive adults. They're filter feeders as adults, consuming algae and vegetation rather than other fish, which seems almost paradoxical for something so large and powerful. Unfortunately, like many river species around the world, The Mekong giant catfish faces serious threats from dam construction, overfishing, and habitat destruction. Their populations have declined dramatically, reminding us how vulnerable even the most impressive river creatures can be when the systems they depend on are altered. Rivers also function as laboratories for evolution in real time. Pollution in rivers can drive rapid evolution in fish populations, with genetic changes occurring over just a few generations in response to contamination. Scientists have documented fish developing resistance to heavy metals, adjusting their metabolism to cope with warmer water temperatures, and changing their reproductive strategies in degraded habitats. This isn't necessarily a hopeful story, though it is a fascinating one. These adaptations often come with trade-offs, and populations under this kind of stress are typically smaller and less genetically diverse. What it demonstrates is that evolution isn't just something that happened in the distant past. It's an ongoing process, and rivers, with their linear habitats and distinct populations, show us how quickly natural selection can reshape life when environmental pressures are strong enough. Some rivers create phenomena that seem to belong more to mythology than reality. One river mouth in Venezuela, where the Catatumbo River flows into Lake Maracaibo, experiences extreme lightning storms that occur up to 260 nights per year, producing as many as 40 lightning strikes per minute during peak activity. This Catatumbo lightning has been occurring for centuries, mentioned in historical records and used by sailors for navigation. The phenomenon happens because winds from the Andes carry moisture that meets methane gas rising from the lake and surrounding wetlands, combined with the specific topography that creates ideal conditions for thunderstorm formation. Night after night, the sky lights up with continuous flashing, a spectacular display that's become known as the largest generator of ozone on the planet. It's a reminder that rivers interact with their environments in complex ways, influencing weather patterns and atmospheric chemistry far beyond the water itself. Even in the most extreme environments on Earth, rivers persist in unexpected forms. An underground river flows beneath Antarctica's ice, carved into the bedrock by the immense pressure and slight warmth from geothermal activity below. This river is unlike any you'd recognize from the surface world. It flows in complete darkness, under millions of tons of ice, through channels that may never have been exposed to sunlight. The water is just barely liquid, kept from freezing by pressure and the Earth's internal heat. Scientists have discovered this and other subglacial rivers using radar and seismic surveys, revealing an entire hidden hydrological system beneath the ice sheets. These rivers may help explain how ice sheets move and change, as water at the base can act as a lubricant, allowing the ice above to flow more rapidly toward the ocean. They also raise tantalizing questions about whether life might exist in these isolated, extreme environments, cut off from the surface world for potentially millions of years, yet still benefiting from that most essential ingredient for life as we know it: liquid water flowing from one place to another, even in the coldest, darkest reaches of our planet. Throughout human history, people have been drawn to rivers with an almost magnetic pull, and this isn't coincidence or mere preference but practical necessity. Many major cities developed along rivers for water and transportation, establishing themselves at strategic points where rivers could serve multiple essential functions simultaneously. Rivers provided drinking water for growing populations, a place to wash and clean, a source of fish and other food. They offered natural highways for moving goods and people long before roads were engineered across difficult terrain. A boat on a river could carry far more cargo than any pack animal, and it could do so with less effort, letting the current assist in at least one direction of travel. Cities grew at river crossings where bridges could be built, at the confluence where two rivers met and multiplied trading opportunities, at the heads of navigation where boats from the ocean could travel no further upstream and goods had to be transferred to other forms of transport. London on the Thames, Paris on the Seine, Cairo on the Nile, Baghdad on the Tigris, Rome on the Tiber, Vienna on the Danube, New York on the Hudson. The list goes on and on, each city owing its location and much of its historical importance to the river that flows through or beside it. Even today, in an age of sophisticated water treatment plants and extensive pipeline systems, rivers remain absolutely fundamental to human survival and prosperity. About 65% of the world's drinking water comes from rivers and their watersheds, meaning nearly 2/3 of humanity depends on these flowing systems for the water they drink every day. When we talk about watersheds, we're referring to all the land area that drains into a particular river, including the countless smaller streams and tributaries that feed it. Rain that falls anywhere within a watershed eventually makes its way to the main river, which means protecting rivers requires protecting entire landscapes, sometimes covering thousands of square miles. The water you drink today might have fallen as rain on a mountain 100 miles away, flowed through a dozen streams, gathered in a river, and finally been drawn out and treated before reaching your tap. That connection between distant rainfall and your glass of water represents both the gift rivers provide and the responsibility humans have to manage watersheds carefully. In some countries, the dependence on rivers is even more pronounced. Rivers provide roughly 75% of United States freshwater for drinking and irrigation, supporting not just cities and towns but the vast agricultural systems that feed hundreds of millions of people. The crops growing across the American Midwest, the fruits and vegetables cultivated in California, the rice fields of Arkansas, all depend on water drawn from rivers or from underground aquifers that rivers help recharge. Irrigation transformed regions that would naturally be too dry for intensive agriculture into some of the most productive farmland on Earth, but this transformation comes with the necessity of managing water carefully, of understanding that rivers have limits, that you can't take out more than flows in without consequences that eventually catch up with you. Some individual rivers bear responsibility for sustaining populations on a scale that seems almost overwhelming. The Colorado River supplies water to about 40 million people across 7 U.S. states and Mexico, flowing from the Rocky Mountains through deserts and canyons before reaching, or in recent decades often failing to reach, the Gulf of California. This river has been so thoroughly diverted, dammed, and allocated that almost every drop is spoken for, claimed by cities like Los Angeles, Las Vegas, and Phoenix, by farms across the Imperial Valley and other agricultural regions, by tribal nations with water rights, by treaty obligations to Mexico. The Colorado has become perhaps the most controlled and contested river in North America, its flow measured and debated and litigated constantly. It demonstrates both how much humans can achieve by harnessing rivers and how precarious our relationship with these water sources can become when demand pushes against the limits of what's available. Rivers serve civilization in ways beyond just providing water to drink or irrigate with. The Mississippi River transports over 500 million tons of cargo annually, making it one of the world's most important inland waterways for commerce. Barges loaded with grain, coal, petroleum products, chemicals, construction materials, and countless other goods move up and down the river, connecting the agricultural heartland to ports on the Gulf of Mexico and from there to world markets. This transportation function reduces the need for trucks and trains, saving energy and money while moving vast quantities of goods efficiently. The ports along the Mississippi, from Minneapolis to New Orleans, form economic hubs where goods are loaded, unloaded, processed, and redistributed. The river essentially functions as a liquid highway, one that never needs repaving, that allows extremely heavy loads to float with relative ease, that has been supporting trade for centuries and continues to be economically vital in the modern era. Humans have also learned to harvest energy from rivers in increasingly sophisticated ways. Hydroelectric dams on rivers generate massive amounts of electricity, converting the potential energy of elevated water into electrical power that lights homes, runs factories, and powers the infrastructure of modern life. Water held behind a dam contains enormous potential energy simply because it's high up. When that water is released and flows downward through turbines, the force of the falling water spins the turbines, which turn generators that produce electricity. This is renewable energy in the sense that the water cycle continuously replenishes the supply, with rain and snow falling in the watershed, gathering in the river, and flowing into the reservoir behind the dam. Some of the largest hydroelectric facilities in the world are truly staggering in their output. Some dams produce more than 100 terawatt-hours of power each year, enough electricity to meet the needs of millions of households. The Three Gorges Dam in China, the Itaipu Dam on the border of Brazil and Paraguay, these structures represent some of the largest engineering projects humans have ever undertaken, fundamentally altering rivers to serve human energy needs. Yet these alterations come with profound consequences. Human activities like dams and pollution alter natural river flows in ways that cascade through entire ecosystems. A dam doesn't just generate electricity or store water for irrigation. It changes the temperature of the river below it, releasing water from deep in the reservoir that's often colder than natural flow would be. It blocks the movement of sediment, so the river below the dam can become sediment-starved, unable to rebuild beaches and sandbars, sometimes even eroding its own channel deeper into the bedrock. It prevents fish from migrating upstream to spawn, disrupting life cycles that evolved over millennia. It changes the timing of high and low flows, smoothing out the natural variation that many species depend on as signals for reproduction or migration. Pollution adds another layer of disruption. Industrial chemicals, agricultural runoff carrying pesticides and fertilizers, sewage from inadequate treatment systems, all of these alter water chemistry, reduce oxygen levels, introduce toxins, and make rivers less able to support the diversity of life they once held. The scale of pollution in some rivers has reached truly troubling levels. Large portions of rivers in some countries are polluted by sewage, with untreated or inadequately treated human waste flowing directly into waterways. This happens in developing nations where infrastructure hasn't kept pace with population growth, but it also occurs in wealthier countries during heavy rains when combined sewer systems overflow and release untreated sewage into rivers. The health consequences can be severe, spreading waterborne diseases, contaminating drinking water sources, and making rivers too polluted for safe recreation. The ecological consequences are equally serious, with excess nutrients from sewage causing algae blooms that deplete oxygen and create dead zones where fish and other animals cannot survive. These polluted rivers represent a failure to treat water systems with the respect they deserve, a short-sighted approach that damages resources millions of people depend on. The combined impact of all these pressures is showing up in the populations of creatures that call rivers home. Freshwater species populations have declined sharply in recent decades, with some studies suggesting that freshwater biodiversity has declined more rapidly than biodiversity in any other ecosystem type, including rainforests. Fish species that once filled rivers in abundance now struggle to maintain viable populations. Freshwater mussels, which filter water and provide habitat for other species, have disappeared from many rivers where they were once common. Amphibians that depend on clean water for reproduction face threats from pollution and habitat loss. River otters, water birds, aquatic insects, all showing declining trends in many regions. These declines aren't just sad from a nature lover's perspective. They're warning signs that the systems we depend on are being degraded, that the rivers providing our drinking water and supporting our agriculture and enabling our commerce are less healthy, less resilient, less able to continue providing these services if current trends continue. The health of river ecosystems and human well-being are not separate concerns but deeply intertwined, and the sharp decline in freshwater species tells us that we need to reconsider how we interact with these ancient, essential, irreplaceable flowing waters that have shaped our world and sustained life for so very long. When people think about rivers and try to imagine the most impressive examples, certain names come to mind almost immediately. Rivers that have become famous not just regionally but globally for their extraordinary characteristics. The Nile River is often considered the longest river in the world, stretching approximately 4,100 miles from its sources in the highlands of East Africa all the way north through the deserts of Sudan and Egypt to the Mediterranean Sea. The Nile has been central to human civilization for thousands of years, with ancient Egypt developing along its banks, entirely dependent on the annual floods that deposited fertile silt across the floodplain and made agriculture possible in an otherwise arid landscape. The river flows through multiple countries, and its water has been the subject of treaties, disputes, and careful management for generations. There's actually some debate about whether the Nile or the Amazon is truly the longest, depending on how you measure and which tributaries you include, but the Nile's claim to this title has been recognized for so long that it remains the river most people think of when they consider length as a defining characteristic. Length is one measure of a river's impressiveness, but volume tells a different story entirely. The Amazon River is the largest river by discharge volume, releasing an almost incomprehensible amount of water into the Atlantic Ocean. The Amazon discharges approximately 55 million gallons per second on average, though during flood season this can increase dramatically. To put that in perspective, the Amazon carries more water than the next 7 largest rivers combined. It accounts for roughly 20% of all river water that flows into the world's oceans. When the Amazon reaches the Atlantic, its freshwater plume extends far out to sea, lowering the salinity of the ocean for miles from shore. Ships sailing along the coast have encountered drinkable freshwater while still out of sight of land, simply because the Amazon's discharge is so enormous. This massive flow reflects the river's huge drainage basin covering much of South America and the heavy rainfall that characterizes the equatorial Amazon rainforest throughout the year. Depth is yet another dimension of river characteristics, and here a different river claims the record. The Congo River is the deepest river in the world, with measured depths exceeding 700 feet in some locations. This extraordinary depth is partly due to the Congo flowing through a rift valley with steep sides, and partly because the river has carved its channel deep into the bedrock over millions of years. The depth means that parts of the Congo remain relatively unexplored, as diving to these depths requires specialized equipment and training. The deep pools create unique habitats, with different water temperatures and oxygen levels at various depths, supporting specialized fish and other organisms adapted to these particular conditions. The Congo is also the world's deepest river in terms of having the greatest overall volume of deep water sections, making it a truly unique river system with characteristics unlike any other major waterway. Moving to Asia, the Yangtze River claims its own superlative. The Yangtze River is the longest river in Asia, flowing approximately 3,900 miles from the Tibetan Plateau eastward across China to the East China Sea. The Yangtze has been central to Chinese civilization for thousands of years, with major cities along its banks and vast agricultural regions depending on its water. The river basin is home to hundreds of millions of people, making it one of the most densely populated river basins in the world. The Yangtze has been extensively modified by human activity, most notably by the Three Gorges Dam, which created a reservoir stretching for over 400 miles upstream. The river supports a unique ecosystem, though many species have declined dramatically or disappeared entirely due to pollution, overfishing, and habitat modification. The Yangtze River dolphin, for instance, is now considered functionally extinct, a sobering reminder of how even mighty rivers can be pushed to their limits by human demands. In North America, river systems often cover vast territories. The Mississippi-Missouri system drains much of North America, with a watershed covering about 40% of the continental United States. This combined river system is often measured together because the Missouri River is actually longer than the Mississippi proper, and the two join near St. Louis before continuing south to the Gulf of Mexico. Water that falls as rain in Montana or Wyoming might eventually flow through the Missouri into the Mississippi and make its way past New Orleans into the Gulf. The Mississippi-Missouri system has been vital for American development, providing transportation, water for agriculture, and defining the geography of settlement patterns across the interior of the continent. The river and its tributaries touch or flow through 31 U.S. states and 2 Canadian provinces, making it one of the most extensive river systems anywhere. Europe's longest river flows through a single country. The Volga River is the longest river in Europe, stretching about 2,200 miles through western Russia from the Valdai Hills northwest of Moscow, flowing generally southward and eastward before emptying into the Caspian Sea. The Volga holds immense cultural significance for Russia, appearing in literature, music, and art as a symbol of the Russian heartland. The river is also heavily industrialized, with numerous cities along its banks and many dams for hydroelectric power and navigation control. The Volga's drainage basin covers a huge portion of western Russia, and despite its length being shorter than rivers on other continents, it carries a substantial flow and has played a crucial role in Russian history, serving as a major trade route for centuries. Some rivers surprise us with characteristics that seem outsized compared to their overall fame. The Parana River in South America reaches depths of over 500 feet in certain sections, making it one of the deeper rivers in the world despite not being as globally famous as the Amazon or Nile. The Parana flows through Brazil, Paraguay, and Argentina, eventually joining with the Uruguay River to form the Rio de la Plata estuary. The river supports important fisheries, provides transportation, and has been dammed for hydroelectric power at several locations. Its depth in some sections creates dramatic underwater landscapes, deep channels carved through rock, pools where large fish can thrive, and complex currents that make navigation challenging in certain areas. Rivers also create land in remarkable ways. The Brahmaputra River, which flows through Tibet, India, and Bangladesh, contains the world's largest river island, Majuli, which covers approximately 200 square miles when water levels are low, though it shrinks during flood season. This inhabited island supports villages, agriculture, and unique cultural traditions, yet it's entirely the product of sediment deposition by the river creating land in the middle of the flow. Majuli has been eroding in recent decades due to changes in the river's flow patterns, raising concerns about the long-term survival of this unique place. The Brahmaputra itself is a powerful river, carrying enormous amounts of water and sediment from the Himalayas, creating and reshaping landscapes constantly as it flows toward its eventual union with the Ganges and journey to the Bay of Bengal. Human engineering has left its mark on rivers worldwide, perhaps nowhere more visibly than on one of Europe's most important waterways. The Danube River is crossed by thousands of bridges, connecting the countries and cities along its banks. The Danube flows through or borders 10 countries, more than any other river in the world, making it a truly international waterway. From its source in Germany's Black Forest to its delta on the Black Sea in Romania and Ukraine, the Danube passes through Vienna, Bratislava, Budapest, and Belgrade, among many other cities. Each crossing required a bridge, and over centuries these have accumulated into the thousands, ranging from ancient stone bridges that have stood for hundreds of years to modern highway bridges carrying heavy traffic. The Danube demonstrates how rivers both divide and unite, creating natural boundaries between territories but also demanding connections, fostering trade and cultural exchange even as they separate different regions. When you start to actually count rivers, the numbers become staggering. There are over 250,000 rivers in the United States alone, if you count all the streams and waterways that meet the technical definition of a river. Most of these are small, unnamed flows that appear on detailed maps but not in general consciousness, yet together they form the intricate network that drains the landscape, collects rainfall, and feeds the major rivers we know by name. Every creek that flows after a storm, every permanent stream in a mountain valley, every moderate-sized river flowing through rural landscapes, they all count in that total. This vast number reminds us that rivers aren't just the famous ones we learn about in school. They're everywhere, threading through the landscape, connecting high elevations to low, moving water from where it falls to where it eventually collects. Each one plays a role in the larger hydrological system, and together they create the living network of flowing water that sustains ecosystems and human communities across the continent and around the world, a reminder that water is always moving, always finding its way downhill, always carving new paths or following ancient ones, in a process that has continued since water first condensed on Earth's surface billions of years ago. When we think about permanence and age, rivers might not be the first thing that comes to mind, since they're defined by constant movement and change. Yet some rivers are among the oldest geological features on Earth, waterways that have persisted through unimaginable spans of time, witnessing the rise and fall of mountain ranges, the drift of continents, the evolution and extinction of countless species. These ancient rivers have maintained their essential character, continuing to flow along paths that were established when the world looked profoundly different from today. They've survived ice ages and warm periods, asteroid impacts and volcanic eruptions, flowing through eras when dinosaurs drank from their banks and continuing on into the age of humans, persistent witnesses to almost incomprehensible stretches of planetary history. In the ancient landscapes of Australia, one river stands out for its extraordinary age. The Finca River in Australia may be over 300 million years old, making it potentially the oldest river in the world. This river flows, at least intermittently, through central Australia in a region that has been tectonically stable for an extremely long time. While younger mountain ranges have risen and eroded away elsewhere, the landscape where the Finca flows has remained relatively unchanged, allowing the river to persist along essentially the same course for hundreds of millions of years. When the Finca first began flowing, the supercontinent Pangaea had not yet fully formed. Early reptiles were just beginning to diversify on land. The forests were dominated by primitive plants that would eventually form coal deposits. Yet even then, water was flowing along this particular path, gathering in this particular drainage, beginning a journey that would continue through the entire age of dinosaurs, through the rise of mammals, through the ice ages, all the way to the present day. Europe, too, holds rivers of almost unimaginable antiquity. The Meuse River in Europe is estimated to be around 320 million years old, making it potentially even older than the Finca. The Meuse flows through France, Belgium, and the Netherlands, a relatively modest river today, but one with a pedigree that stretches back to the Carboniferous period, when Earth's climate was warm and humid, when vast swamp forests covered much of the land, when the plants growing in those swamps would eventually be compressed into the coal deposits that fueled the Industrial Revolution. The Meuse has seen so much. It flowed when the region was near the equator, before continental drift moved Europe to its current position. It continued flowing as ice sheets advanced and retreated during multiple ice ages. It witnessed the arrival of humans in Europe and has been part of human history throughout recorded time, yet human history represents just the tiniest fraction of this river's existence. Even in North America, a relatively young continent in terms of exposed surface rocks, some rivers reach back through vast stretches of time. The New River in the United States dates back more than 260 million years, flowing through Virginia, West Virginia, and North Carolina in a path that was established long before the Appalachian Mountains took their current form. In fact, the New River, despite its name suggesting youth, is considered one of the oldest rivers in the world. It has cut through the landscape, maintaining its course even as the land around it was uplifted, creating deep gorges and dramatic scenery. The New River Gorge is now protected as a national park, a place where you can stand beside water that has been flowing along this path since before the dinosaurs, since before the Atlantic Ocean opened, since a time when all the world's land masses were joined together in configurations that would be unrecognizable on a modern map. Pennsylvania's major river also claims remarkable antiquity. The Susquehanna River is over 300 million years old, flowing from upstate New York through Pennsylvania to the Chesapeake Bay. This river predates not only the current landscape but the entire Appalachian mountain range in its present form. As the mountains were uplifted, the Susquehanna maintained its course, cutting down through the rising rock, creating water gaps where it flows through ridges that formed after the river was already established. This is called an antecedent river, one that is older than the mountains it crosses, and the Susquehanna is a prime example. Walking along its banks, you're tracing a path that water has followed since before the age of reptiles, a continuity of flow that spans an almost incomprehensible stretch of Earth history. The age of some rivers tells us they're ancient, but other rivers reveal that drainage patterns can completely reverse over geological time. The Amazon River once flowed in the opposite direction before the Andes rose, carrying water from east to west toward the Pacific Ocean rather than from west to east toward the Atlantic as it does today. This reversal happened because the Andes mountain range, which runs along the western edge of South America, was uplifted over millions of years by the collision of tectonic plates. As the mountains rose, they blocked the Amazon's original westward path, causing water to pool in a vast inland sea or series of lakes. Eventually, the water found a new outlet toward the east, cutting through the landscape toward the Atlantic, and the Amazon was reborn flowing in the opposite direction. This transformation reshaped the entire continent's hydrology, creating the conditions for the modern Amazon basin and the rainforest it supports, all because the slow but inexorable movement of Earth's crust redirected one of the world's greatest rivers. Not all ancient rivers have survived to the present day. The Saraswati River, mentioned in ancient Indian texts as a mighty river that supported early civilization, disappeared due to ancient climate changes that altered rainfall patterns and possibly diverted the tributaries that fed it. The Saraswati is described in the Vedas and other ancient writings as a great river flowing between the Yamuna and Sutlej rivers, but today no perennial river exists in that location. Archaeological and geological evidence suggests that a significant river system did exist there thousands of years ago, with dry riverbeds visible in satellite imagery and ancient settlements distributed along what would have been the river's course. The disappearance of the Saraswati, whether due to tectonic changes that diverted its tributaries, climate shifts that reduced rainfall, or both, represents a dramatic example of how even mighty rivers can vanish when conditions change sufficiently, leaving behind only memories, dry channels, and questions about exactly what happened. Some rivers are dramatically unstable over much shorter timescales. The Yellow River in China has changed course many times due to sediment buildup, earning it a reputation as one of the most unpredictable and dangerous rivers in the world. The Yellow River carries an enormous load of silt eroded from the Lurs Plateau, giving the water its characteristic yellow-brown color. As the river flows across the North China Plain, this sediment settles out, gradually raising the riverbed. In some sections, the bed has been raised so high that the river now flows above the surrounding countryside, contained only by levees. When these levees fail during floods, the river can break out and carve an entirely new course, sometimes shifting hundreds of miles from its previous path. Historical records document numerous course changes over the centuries, with the river sometimes flowing north of the Shandong Peninsula and sometimes south of it, each shift bringing catastrophic flooding and forcing entire populations to relocate. The Yellow River demonstrates how the very material rivers carry can become the agent of their own transformation. A more recent example of dramatic river behavior occurred in the 20th century. The Kosi River in India and Nepal shifted over 100 kilometers westward in a single flood event in 2008 when a breach in an embankment allowed the river to abandon its controlled course and return to a channel it had occupied decades earlier. This wasn't a gradual migration, but a sudden, catastrophic shift that displaced millions of people, destroyed villages and farmland, and demonstrated how precarious human control over rivers can be. The Kosi is known as the Sorrow of Bihar for its history of devastating floods and course changes, with the river's fan-shaped alluvial plain showing evidence of it having occupied a wide range of channels over the centuries. The 2008 shift was a reminder that rivers have their own logic, their own preferences for where to flow, and that human engineering, while it can constrain and redirect rivers for periods of time, must always contend with the fundamental nature of flowing water seeking the most efficient path to lower elevation. Rivers aren't unique to Earth, and perhaps nothing drives home the fundamental nature of rivers as geological phenomena more than looking to other worlds. Ancient riverbeds on Mars show that liquid water once flowed there, carving channels, forming deltas, creating landscapes that look remarkably similar to river systems on Earth. These Martian rivers flowed billions of years ago, when Mars had a thicker atmosphere and warmer temperatures that allowed liquid water to exist on the surface. The dry channels remain today, preserved in the cold, thin Martian air, testament to a time when the red planet was more Earth-like, when water cycled through the atmosphere and across the surface, when rivers gathered in networks and flowed toward lower elevations just as they do on Earth. The presence of these ancient riverbeds tells us that the physics of flowing water creates similar patterns regardless of the planet, and that Mars once had conditions that might have supported life, at least microbial life, in those long-vanished rivers. Looking at Mars reminds us that rivers are fundamental expressions of how water and gravity interact with planetary surfaces, processes that aren't unique to Earth but rather represent universal principles that apply wherever liquid water can flow. The Amazon River continues to surprise scientists with discoveries that challenge assumptions about what can exist where. A massive coral reef system exists at the Amazon River Delta, which seems almost contradictory since coral reefs typically require clear, sunlit water and the Amazon discharges vast amounts of sediment-laden freshwater into the Atlantic. Yet this reef exists, stretching for hundreds of miles beneath the murky plume where the river meets the ocean. The reef was only discovered relatively recently, in 2016, because the conditions seemed so unlikely for coral growth that no one had looked carefully in that location. The corals and sponges that make up this system have adapted to low light conditions, surviving in water that receives far less sunlight than typical reef environments. The reef is home to numerous species of fish and other marine life, creating an ecosystem in conditions that would seem hostile to such biodiversity. This discovery reminds us that life finds ways to thrive in unexpected places, and that even rivers as well studied as the Amazon can still hold secrets waiting to be revealed. The sheer scale and power of the Amazon creates unusual situations in terms of human infrastructure. There are no permanent bridges spanning the full width of the Amazon River, a remarkable fact given how thoroughly humans have engineered connections across waterways worldwide. The Amazon is simply too wide, too deep, too powerful, and flows through regions too sparsely populated to justify the enormous expense and engineering challenge of building a bridge across its main channel. Where the Amazon is narrowest, it's still miles wide. During flood season, it can expand to widths of 30 miles or more in some sections. The water depth and strong currents would require bridge supports of extraordinary height and strength. The occasional bridges that do exist cross tributaries or narrower sections of the system, but the main Amazon remains unbridged, with ferries and boats providing the only way to cross, maintaining a separation between the northern and southern banks that has existed throughout human history in the region. Below the Amazon, hidden from view, another river follows a similar path. An underground river, flowing through porous rock layers 4 kilometers below the surface, follows a course roughly parallel to the Amazon for much of its length. This underground system, sometimes called the Hamza River after the scientist who studied it, isn't a river in the traditional sense with a defined channel, but rather a slow movement of water through permeable rock layers, flowing at rates measured in meters per year rather than meters per second. The existence of this deep aquifer system has implications for understanding the region's hydrology, as it represents an enormous reservoir of water moving through the subsurface. The discovery of this underground flow added another layer to our understanding of the Amazon basin as not just a surface river system but a three-dimensional hydrological complex with water moving both above and below ground, cycling through different parts of the system on different timescales. The Amazon River's name carries echoes of ancient mythology and the early European exploration that brought South America into the historical record of the Old World. The Amazon River was named after mythical warrior women from Greek mythology, the Amazons, who were said to be fierce fighters living in a society without men. Spanish conquistador Francisco de Orellana encountered indigenous warriors along the river in the 1540s, and according to the expedition's chronicler, some of these warriors were women who fought alongside the men. Whether this account was accurate or embellished, Orellana drew a parallel to the legendary Amazons, and the name stuck, becoming attached to the river and eventually to the entire region. It's a name that captures something of the river's character, its power and untamed nature, even if the connection to ancient Greek myth is tenuous at best. The indigenous peoples of the region have their own names for the river and its sections, names that reflect thousands of years of living alongside this immense waterway. The Amazon's interaction with the ocean creates phenomena that seem to defy the normal behavior of rivers. A tidal wave, known locally as the pororoca, can travel upriver on the Amazon during full moons and new moons when tidal forces are strongest. This isn't a tidal wave in the sense of a tsunami, but rather a tidal bore, a wave of water that forms when the incoming ocean tide pushes against the river's outflow. The pororoca can be several meters high and travel upstream at speeds of 25 kilometers per hour or more, creating a roaring wall of water that surfers have actually ridden for kilometers at a time. The phenomenon occurs primarily during the spring tides twice a month and can be heard approaching from miles away. Trees along the banks can be uprooted by the force of the wave. The pororoca is a reminder that the Amazon, despite its enormous discharge, still exists in conversation with the ocean, with tidal influences reaching hundreds of miles upstream during certain times of the month. The Amazon has challenged humans in many ways, but few challenges are as extreme as attempting to swim its entire length. One person has swum the entire length of the Amazon River, a Slovenian endurance swimmer named Martin Strel, who completed this extraordinary feat in 2007. The swim took 66 days, covering approximately 5,200 kilometers from the source tributaries in Peru to the river's mouth in Brazil. Strel faced numerous dangers, including piranhas, crocodiles, river pollution, and simple exhaustion. He swam for up to 10 hours per day, accompanied by a support boat, dealing with infections, sunburn, and the psychological challenge of swimming through what must have seemed like an endless expanse of water. The achievement required not just physical endurance but mental toughness of an extraordinary degree, pushing through pain and fear day after day, with the only way out being to continue forward until the ocean was finally reached. Strel didn't stop with the Amazon. The same swimmer also completed the Danube, Mississippi, and Yangtze rivers, establishing himself as one of the world's most accomplished long-distance river swimmers. Each of these swims presented unique challenges, different dangers, different types of pollution and environmental conditions. The Danube swim in 2000 covered 3,004 kilometers in 58 days. The Mississippi swim in 2002 covered 3,734 kilometers in 68 days. The Yangtze swim in 2004 covered 4,003 kilometers in 51 days, despite heavily polluted water that made him seriously ill. These achievements aren't just athletic accomplishments but also brought attention to the pollution and environmental challenges facing major rivers worldwide. Strel swims demonstrated both human capability and the degraded condition of rivers that millions depend on, using his body as an instrument to measure and publicize the state of the world's waterways. Despite the Amazon's lack of bridges across its main channel, human infrastructure in the basin has been developing. The first bridge across a major Amazon tributary, the Rio Negro, opened in 2010 near Manaus, Brazil, finally connecting the city to areas on the opposite bank by road rather than requiring ferry crossings. The Rio Negro Bridge is over 3.5 kilometers long, a substantial engineering achievement in itself, though it crosses a tributary rather than the main Amazon stem. The bridge transformed transportation and economic development in the region, making it easier to move goods and people, opening up areas that were previously more isolated. The construction took several years and required careful engineering to deal with the river's seasonal variations in water level, which can differ by up to 15 meters between low and high water periods. The Rio Negro itself is a remarkable river in its own right. The Rio Negro is one of the Amazon's largest tributaries, carrying approximately 14% of the water that eventually flows from the Amazon into the Atlantic. The Negro's name, meaning Black River in Portuguese and Spanish, comes from its dark, tea-colored water, which results from tannins and other organic compounds leached from decaying vegetation in the forests through which it flows. Where the Rio Negro meets the Amazon's muddy, lighter-colored water near Manaus, the two rivers flow side by side for several miles without mixing, creating a dramatic visual boundary called the meeting of waters. The Negro's water is more acidic and slightly warmer than the Amazon's, and these differences in temperature, density, and speed allow the two rivers to maintain their distinct appearance for a considerable distance before finally blending together. The Amazon sources lie high in the Andes Mountains, fed by numerous rivers that begin at extraordinary elevations. The Marañón River has one of the highest altitude sources of any major river, beginning at over 5,000 meters above sea level in the Peruvian Andes. The Marañón is considered by many geographers to be the main source of the Amazon, though this is debated as several rivers have claims to being the ultimate source depending on how you measure length and water volume. From its high-altitude beginnings in glacial lakes and snowmelt, the Marañón descends through one of the world's deepest canyons, deeper in some sections than the Grand Canyon, before emerging onto the lowlands where it joins with the Ucayali River to form what is officially called the Amazon. The journey from these cold, high-altitude sources down through mountain canyons, across vast rainforests, and finally to the tropical Atlantic represents one of the most dramatic transitions any river system makes anywhere on Earth, spanning virtually every climate and ecosystem found in South America over the course of thousands of kilometers. Rivers that flow through major cities become landmarks in themselves, their waters woven into the identity of the places they pass through. The River Thames in London has more than 200 bridges spanning its length, from small footbridges in the upper reaches to massive structures like Tower Bridge and London Bridge in the heart of the city. This extraordinary number reflects centuries of development, with each era adding its own crossings to connect neighborhoods, facilitate commerce, and accommodate growing populations. The bridges range from medieval stone structures that have stood for hundreds of years to sleek modern designs in glass and steel. Some carry trains, some roads, some pedestrians only. Together they create a network that makes the Thames not a barrier dividing London, but rather a central axis around which the city has organized itself, with the river flowing through the middle and bridges stitching the two sides back together at regular intervals. The Thames, despite flowing through one of the world's great cities, begins in a surprisingly modest location. The Thames begins in a small meadow in England, in the Cotswolds region of Gloucestershire, where a spring called Thames Head marks the traditional source. For much of the year, the spring is dry, and the river actually begins flowing a bit downstream where groundwater reaches the surface more reliably. This humble beginning, just a trickle in a pastoral landscape of grazing sheep and rural farmland, seems almost impossibly distant from the wide, tidal river that flows past the Houses of Parliament and the Tower of London. Yet every river starts somewhere small, and the Thames demonstrates how a modest source can grow through the addition of countless tributaries into a river capable of supporting a metropolis of millions, a working waterway that has carried trade and powered industry for 2,000 years of human history. The improving environmental health of the Thames has brought unexpected visitors. Seals have been spotted far upstream on the Thames in recent decades, travelling well past central London into areas where they would have been inconceivable during the heavily polluted mid-20th century. The Thames was once so polluted that it was declared biologically dead, too contaminated to support fish or most other life. Decades of environmental regulation, improved sewage treatment, and reduced industrial pollution have allowed the river to recover dramatically. Fish populations have rebounded, and with the fish came predators. Grey seals and harbour seals now regularly swim up the Thames from the North Sea, hunting for fish in waters that had been devoid of life within living memory. These sightings delight Londoners and serve as visible proof that environmental recovery is possible, that rivers can heal when given the chance, when pollution is controlled and ecosystems are allowed to rebalance. The Thames has witnessed extraordinary moments in history, including times when it froze solid enough to support entire festivals on its surface. Frost fairs were once held on the frozen Thames during particularly cold winters between the 17th and 19th centuries, with the most famous occurring during the Little Ice Age when temperatures across Europe were significantly colder than today. The river would freeze thick enough that people could walk across it, and enterprising vendors would set up booths selling food, drinks, and souvenirs. There were ice skating races, puppet shows, and even entire oxen roasted on the ice. The last Frost Fair occurred in 1814, and the Thames hasn't frozen in central London since. The end of these events came partly from gradual climate warming but also from engineering changes, including the removal of the old London Bridge, which had multiple narrow arches that slowed the river's flow and made it more likely to freeze. The replacement bridge allowed water to flow more freely, and the Thames has remained unfrozen ever since, though those frost fairs remain a fascinating glimpse into a colder era. London's relationship with rivers is more complex than just the Thames. Nearly 20 rivers flow hidden beneath modern London, buried under streets and buildings, converted into sources or culvert underground as the city expanded. Rivers like the Fleet, the Tyburn, the Westbourne, and others once flowed openly through what is now the urban landscape, providing water, powering mills, and defining neighborhood boundaries. As London grew, these rivers became polluted and were gradually covered over, their courses followed by streets or hidden entirely beneath the city's infrastructure. Some can still be heard flowing beneath grates. Occasional maintenance access points reveal water still flowing in its ancient channel, now confined to brick tunnels. These hidden rivers represent layers of history, reminding us that the land beneath cities has its own geography, its own hydrology, continuing to function even when invisible to the people walking above. River engineering has produced some truly remarkable structures. The Elbe River in Germany features a bridge that carries ships over land, the Magdeburg Water Bridge, which allows boats to cross from one canal to another, passing over the Elbe River itself. This structure is essentially an elevated canal, a water-filled channel held up by a massive concrete aqueduct nearly a kilometer long. Boats can sail along the Mittelland Canal, float across the water bridge passing high above the Elbe, and continue on the Elbe-Havel Canal without having to descend to the river level and navigate a more circuitous route. The bridge demonstrates the extent to which humans have engineered waterways for transportation, creating networks where water flows at multiple levels, where rivers and canals intersect in three-dimensional arrangements that would have seemed like fantasy just a few generations ago. Not all European rivers have been so heavily modified. The Vosa River, flowing through Albania and Greece, is one of Europe's last wild free-flowing rivers, running from the mountains to the Adriatic Sea without being interrupted by dams or major engineering structures along its main channel. The Vosa represents something increasingly rare in Europe, where most rivers have been dammed, channelized, or otherwise significantly altered. The river's seasonal flows vary dramatically, swelling with snowmelt in spring and dwindling in summer, creating constantly shifting channels and gravel bars. The ecosystem supports rare species including migratory birds and endemic fish. There have been ongoing efforts to protect the Vosa from dam construction, with conservationists arguing that the river's wild character is valuable precisely because it's become so uncommon, a baseline for understanding what rivers are like when allowed to function without human control. Italy's longest river carries both water and history. The Po River is Italy's longest river entirely within one country, flowing eastward across northern Italy from the Alps to the Adriatic Sea. The Po Valley is one of Italy's most productive agricultural regions and most densely populated areas, with major cities like Turin and several smaller cities along the river's course. The Po has been central to Italian history for thousands of years, forming a natural transportation corridor and defining the geography of the northern part of the country. The river carries heavy loads of sediment, extending its delta gradually into the Adriatic, creating new land over centuries. Like many heavily used rivers, the Po faces challenges from pollution, over-extraction of water for irrigation, and altered flow patterns, but it remains vital to Italy's economy and identity. Art and rivers sometimes intersect in unexpected ways. A photograph of the Rhine River, taken by Andreas Gursky, sold for millions of dollars, making it one of the most expensive photographs ever sold. Gursky's image Rhine 2 shows the river in a highly manipulated form, digitally altered to remove buildings and industrial elements, presenting the Rhine as a series of horizontal bands of color: green grass, gray path, gray river, gray path, green grass, and pale sky. The photograph raises questions about representation and reality, about what we expect rivers to look like versus what they actually look like in the modern world. The Rhine is one of Europe's most heavily trafficked and industrialized rivers, yet Gursky's image strips away that context, creating an abstract, almost minimalist composition. The photograph's high price reflects the art market's valuation of Gursky's vision and technique, but it also suggests something about our relationship with rivers, our desire to see them as pure and natural even when the reality is far more complex. In Africa, rivers have shaped human history and commerce for millennia. The Niger River supported African trade routes for centuries, flowing in a distinctive arc through West Africa, first heading northeast away from the coast before curving around and flowing southeast to its delta on the Atlantic. This unusual course puzzled European geographers for a long time, but for the peoples living along its banks, the Niger was a highway connecting diverse cultures and enabling the movement of goods including gold, salt, textiles, and agricultural products. Great empires rose along the Niger, including Mali and Songhai, their wealth and power based partly on controlling trade along the river. Cities like Timbuktu became centers of commerce and learning, positioned at crucial points where river transport connected with overland caravan routes. The Niger's role in African history demonstrates how rivers function as more than just sources of water, how they become organizing principles for human geography, creating pathways that encourage interaction and exchange, shaping the development of civilizations in ways that persist long after specific empires have faded into history. Rivers come in an astonishing variety of sizes, and at one extreme we find waterways that barely seem to deserve the name yet technically qualify. The Reprua River in the country of Georgia is considered the shortest river in the world, flowing only about 60 feet from its source in a cave system to where it empties into the Black Sea. This tiny river barely gives you time to register that it exists before it's already reached its destination. The Reprua emerges from the Krubera Cave, one of the deepest caves in the world, bringing underground water to the surface for just a brief moment before merging with the sea. The designation of shortest river is somewhat arbitrary and depends on definitions, as there are many short waterways around the world, but the Reprua is consistently cited as the title holder. It reminds us that rivers exist on every scale, from continent-spanning systems to flows you could easily step across, and that each plays its role in the hydrological systems of its region. Sometimes rivers need to be redirected to solve problems created by human development. The Chicago River was artificially reversed to control pollution, flowing away from Lake Michigan instead of into it. Originally, the river flowed into the lake, which was Chicago's source of drinking water. But as the city grew, the river became heavily polluted with sewage and industrial waste. By the late 19th century, this was causing serious public health problems, contributing to disease outbreaks. Engineers designed and constructed a system of canals that effectively reversed the river's flow, sending Chicago's wastewater away from the lake and down toward the Mississippi River system instead. This was an enormous engineering project, one of the most ambitious of its era, involving moving massive amounts of earth and concrete to create new channels. The reversal was completed in the early 20th century and remains in effect today, though it has created new problems for the regions downstream and ongoing concerns about invasive species potentially moving between the Great Lakes and Mississippi River watersheds through these artificial connections. In the coldest regions of the planet, rivers transform seasonally into something quite different. The Lena River in Siberia forms a seasonal ice road during winter months when temperatures drop so low that the river freezes solid enough to support vehicles. These ice roads become vital transportation routes in regions where permanent roads are scarce or non-existent, allowing trucks to carry supplies to remote communities and industrial sites. The Lena is one of the largest rivers in the world by discharge, yet for months each year it's locked in ice thick enough that heavy trucks can safely cross. As spring arrives and temperatures rise, the ice begins to break up in dramatic fashion, with ice jams sometimes creating temporary dams that cause flooding when they finally give way. The seasonal cycle of freezing and thawing defines life along the Lena, with transportation patterns, economic activity, and daily life all adapting to whether the river is liquid or solid at any given time. Rivers can create conditions that seem almost impossible. One river in Peru, the Shunayatinpishka or Boiling River, reaches near boiling temperatures due to geothermal heat, with water temperatures measured as high as 93 degrees Celsius in some sections. The river flows through the Amazon rainforest, heated by geothermal activity deep underground, emerging at temperatures hot enough to kill any animal that falls in and hot enough to make the air above shimmer with steam. Local legend held that such a river existed, but scientists long dismissed these stories as myth or exaggeration until a geologist investigated and confirmed that yes, this river really does approach boiling temperature along much of its length. The mechanism isn't fully understood but involves water circulating deep underground where it's heated by Earth's interior before returning to the surface through fault lines. The boiling river creates its own microclimate and supports unique thermophilic microorganisms adapted to extreme heat, while the surrounding forest continues in its typical tropical patterns just meters away from water hot enough to brew tea. Some rivers are famous not for their size or length but for their extraordinary beauty. Cono Cristales in Colombia is known as the River of Five Colors or the Liquid Rainbow, displaying vivid hues of red, yellow, green, blue, and black at certain times of year. This phenomenon occurs when a unique aquatic plant, Macarinia clavigera, blooms in the riverbed, turning brilliant red and pink. Combined with the natural colors of sand, water, algae, and rock, the river becomes a stunning natural artwork visible primarily between July and November when water levels and sunlight are optimal for the plant's display. The river flows through remote areas of Colombia that were long inaccessible due to conflict but have more recently opened to limited tourism, allowing visitors to witness this remarkable spectacle. Cono Cristales demonstrates how specific combinations of geology, biology, and hydrology can create conditions found nowhere else, rivers that are unique not just in degree but in kind. Rivers feed some of the world's most spectacular waterfalls. Angel Falls in Venezuela, the world's highest waterfall at over 3,000 feet, is fed by a river that flows from the top of a tepui, one of the distinctive flat-topped mountains of the region. The river, called the Chu Run, flows across the summit plateau before reaching the edge and plunging off the cliff in a drop so high that much of the water turns to mist before reaching the pool at the bottom. The falls were unknown to the outside world until the early 20th century and named after Jimmy Angel, an American aviator who flew over them in 1933. The height of Angel Falls is difficult to comprehend, more than twice the height of the Empire State Building, a sheer drop that takes the water falling from the top nearly 15 seconds to reach the bottom, though in reality the water breaks up and doesn't fall as a single stream for most of that distance but becomes spray and mist that creates rainbows and coats the surrounding jungle with moisture. While Angel Falls claims the record for height, another waterfall holds a different record. Kone Falls on the Mekong River in Laos is the widest waterfall in the world, stretching for over 35,000 feet across at maximum width. Rather than a single dramatic drop, Kone Falls is a series of rapids and cascades spread across a complex landscape of channels, islands, and rock formations. During the wet season, the volume of water flowing over the falls is tremendous, estimated at over 400,000 cubic feet per second. The falls create a barrier to navigation on the Mekong, preventing boats from passing and historically limiting trade and travel. The sound of the water crashing over rocks can be heard for miles. The area around the falls supports unique ecosystems, including the critically endangered Irrawaddy dolphin, which lives in pools just below the falls, somehow surviving in the turbulent conditions. Tidal effects can create dramatic changes in river levels far inland from the ocean. The River Severn in Britain has one of the highest tidal ranges on Earth, with differences between high and low tide of up to 50 feet in the estuary. This extreme tidal range creates the Severn Bore, a tidal wave that travels upstream when the incoming tide is particularly strong, similar to the Pororoca on the Amazon but occurring in a very different climate and context. The bore can be several feet high and is popular with surfers who ride it for miles upstream. The Severn's tidal range is due to the funnel shape of the estuary, which concentrates tidal energy as water is forced into an increasingly narrow channel. The extreme tides influence life and activity for miles inland, with riverside communities having to accommodate massive changes in water level twice daily, designing infrastructure to work whether the river is full or revealing wide expanses of mudflat. Rivers can acquire dark reputations based on tragic histories. One river in Korea, the Nakdong River in certain sections, has been nicknamed the River of the Dead due to historical battles and conflicts that occurred along its banks, particularly during the Korean War when intense fighting took place around the Nakdong perimeter. The river became associated with death and suffering during that period, though today it serves as a major water source and the subject of environmental protection efforts. The nickname reflects how rivers can become deeply embedded in cultural memory and collective trauma, how waterways that might seem neutral geographical features can carry enormous emotional and historical weight for the people who live near them, who remember what happened on their banks, whose family histories intertwine with the river's story in ways both beautiful and painful. Finally, it's worth remembering that not everywhere has rivers as we typically imagine them. 17 countries in the world have no permanent rivers, located primarily in desert regions or small island nations where the climate is too dry or the land area too small to support rivers that flow year-round. Countries like Saudi Arabia, Libya, and several small island nations in the Middle East and Pacific rely instead on groundwater, desalination, or seasonal wadis that flow only after rare rains. Living without permanent rivers requires completely different approaches to water management, different cultural relationships with water, different expectations about how water should be stored, distributed, and valued. For these countries, the absence of rivers makes water security a constant concern and often a driver of technology adoption, leading to some of the world's most advanced desalination facilities and water conservation systems. The absence of something we take for granted in most parts of the world highlights just how fundamental rivers are to the human experience. How much of our civilization has been built around the assumption that fresh water will flow reliably from higher ground to lower, gathering in channels we can access, sustaining life in all its diversity and abundance. Some rivers display colors that seem almost supernatural, created by the unique chemistry of the rocks and minerals they flow through. One river in Spain, the Rio Tinto, appears red due to iron-rich minerals dissolved in the water, giving it a striking crimson or orange hue that looks more like something from another planet than a typical river on Earth. The color comes from iron salts and sulfur compounds leached from deposits of iron pyrite and other minerals that have been mined in the region since ancient times. The water is highly acidic, with pH levels sometimes approaching that of stomach acid. Yet remarkably, extremophile microorganisms thrive in these harsh conditions. Scientists study the Rio Tinto as an analogue for potential life on Mars, since the chemical conditions are similar to what may exist on the red planet. The river has flowed red for thousands of years, mentioned in ancient texts, a reminder that not all rivers are blue or brown or clear, that the chemistry of place can transform water into something strange and beautiful and unexpected. Rivers sometimes bring surprises to cities far from their natural habitats. A Nile crocodile was once found living in Paris Source, discovered in the 1980s, having somehow made its way into the underground waterways beneath the city. The crocodile was likely an escaped or released pet that found its way into the Source system and managed to survive for some period in the dark, warm tunnels beneath Paris. The Source carry enough water to sustain a large reptile, and the temperature, warmed by the heat of the city, was evidently tolerable enough for the animal to persist. The discovery sparked both fascination and concern, raising questions about what else might be living in the hidden spaces beneath major cities, in the rivers and streams that have been buried and forgotten but continue to flow, creating ecosystems we rarely think about and seldom explore. Rivers can hide history beneath their waters, preserving it until changing conditions bring it back to light. An ancient Egyptian temple was discovered underwater in the Nile, submerged for centuries, its ruins preserved in the river's sediments. The Nile has been central to Egyptian civilization for thousands of years, and numerous structures were built along its banks or on islands in its course. Changes in the river's level, whether from natural variation or modern dam construction, have submerged some sites while exposing others. Underwater archaeology along the Nile has revealed statues, building foundations, entire temples that were lost to rising waters or shifting channels. These discoveries connect us directly to ancient peoples who worshipped by this river, who depended on its floods, who built monuments expecting them to last forever but unable to anticipate how the river itself would change and claim their creations, holding them in preservation beneath the water until modern techniques could reveal what had been hidden. Sometimes rivers are named for the distinctive wildlife that early explorers encountered. Australia's Swan River was named by Dutch explorer Willem de Vlaming in 1697 for the black swans living there, birds that were unknown to Europeans at the time since all European swans are white. The discovery of black swans was startling to people who had never imagined that swans could be any color but white, and the phrase black swan has entered the language as a metaphor for unexpected events that challenge our assumptions about what's possible. The Swan River flows through Perth, Western Australia's largest city, and the black swans remain there today, a distinctive part of the river's identity and the regional ecology. The naming reflects that moment of first encounter, when Europeans were still mapping and cataloguing the wildlife of a continent that was utterly new to them, finding species that challenged their understanding of the natural world. Rivers are constantly reshaping the land, and in some cases we can watch this process happening in real time. The Atchafalaya River in Louisiana is actively building a new delta, depositing sediment at a rate that's creating new land where the river enters the Gulf of Mexico. The Atchafalaya is actually a distributary of the Mississippi, carrying about 30% of the Mississippi's flow through a separate channel to the Gulf. Without human intervention, the Atchafalaya would likely capture even more of the Mississippi's flow, potentially leaving New Orleans on a much diminished river. Engineers have built structures to maintain the current flow distribution, but the Atchafalaya continues to build its delta, extending Louisiana's coastline, creating new marshes and wetlands, demonstrating the land-building power of rivers when they're carrying sufficient sediment. This is particularly significant for Louisiana, which is losing coastal land to subsidence and sea level rise in other areas, making the Atchafalaya's delta building activity a rare example of natural land creation in a state struggling with land loss. Sometimes rivers become powerful symbols of environmental degradation. Ohio's Cuyahoga River has caught fire multiple times from pollution, most famously in 1969 when flames rose several stories high from oil and industrial chemicals floating on the water's surface. The image of a river burning became a galvanizing moment for the environmental movement in the United States, helping to build support for the Clean Water Act and other environmental regulations. The Cuyahoga had actually caught fire several times before, dating back to the 1860s, as industrial pollution from Cleveland and other cities turned the river into essentially a waste disposal system for whatever factories wanted to dump. The 1969 fire, though not the largest or most damaging, occurred at a moment when environmental awareness was growing and photographs and news coverage spread widely, shocking people who couldn't believe a river could be so polluted it would burn. The Cuyahoga has since been cleaned up significantly, with fish returning and recreational use expanding, demonstrating again that recovery is possible when society decides to prioritize it. Rivers can become repositories for unexpected objects and forgotten history. Thousands of tombstones lie at the bottom of the Delaware River, dumped there in the mid-20th century when cemeteries were relocated or when old gravestones were replaced and the originals were disposed of by simply throwing them in the river. These stones, marking graves from the 18th and 19th centuries, now rest underwater, their inscriptions slowly eroding, creating an eerie underwater graveyard of markers separated from the bodies they were meant to memorialize. The practice of dumping tombstones in rivers was unfortunately common in various locations when cemeteries were moved for development or when families chose to replace old, weathered markers with new ones. The stones in the Delaware serve as a reminder of how rivers have been treated as convenient disposal sites for all manner of things humans wanted to be rid of, with little thought to what this meant for the river itself or what these objects would mean to future generations who might discover them. Even in cities that have thoroughly buried and built over their natural waterways, those rivers continue to exist, flowing unseen beneath the urban landscape. A ghost river still runs beneath Manhattan, the Minetta Brook, which once flowed above ground through Greenwich Village before being buried in soars in the 19th century. The brook still flows, carrying water from springs and collecting runoff, following its ancient path beneath buildings and streets, occasionally making its presence known when it floods basement spaces during heavy rains. New Yorkers walking through the West Village have no idea that beneath their feet, water is flowing in the same channel it followed for thousands of years before the city was built. These ghost rivers exist in many cities, forgotten but persistent, reminding us that urban development doesn't eliminate natural hydrology but simply hides it, forces it underground, makes us forget it exists until something goes wrong and we're reminded that the land beneath the city still has its own geography, its own flows, its own insistence on following the paths that gravity and geology dictate. Throughout history, rivers have even been weaponized in conflicts between peoples and nations. Historical armies have rerouted rivers to destroy enemy cities, either flooding them by diverting rivers toward them or drying them up by redirecting their water away. Ancient Mesopotamian texts describe armies diverting rivers to flood enemy territories or to deprive cities of water. The Mongols famously diverted the Amu Dorya River away from the city of Urgench, destroying the irrigation systems that supported the population. More recently, dam destruction has been a military tactic in various conflicts, using rivers' power to cause devastation downstream. These acts demonstrate how fundamental rivers are to human survival, how controlling water means controlling life itself, and how rivers can shift from being sources of sustenance to weapons of war depending on who controls them and what decisions are made about where their water should flow. As we come to the end of this journey through river facts and river stories, it's worth reflecting on the overarching theme that connects everything we've explored. Rivers have shaped landscapes, ecosystems, and human civilizations throughout history, carving valleys and canyons, creating deltas and floodplains, providing the water that life requires, enabling transportation and trade, defining boundaries between territories, inspiring myths and religions, supporting biodiversity from microscopic organisms to massive fish and mammals, challenging us with floods, sustaining us with their flows, changing course over geological time, persisting through ice ages and warm periods, being altered by human activity yet continuing to flow, continuing to shape the world even as we try to control them. Rivers are more than just water flowing from high elevations to low. They're dynamic systems that connect mountains to oceans, rainfall to lakes, past to present, carrying not just water and sediment but history and meaning, shaping the planet and everything on it through their patient, persistent, endless movement toward the sea. Understanding rivers means understanding some of the most fundamental processes that make Earth a living, changing, endlessly fascinating planet, and recognizing that these flowing waters will continue shaping our world long after we're gone, following the same basic principles they followed for billions of years, responding to gravity and geology, adapting to climate, carving new paths when necessary, but always flowing, always moving, always seeking the lowest point, always returning water to the sea so that the cycle can begin again.